Hello everyone, I am Levent Ekin. My presentation topic is Huygen's construction for a spherical plane wave. I will talk about. I have content. Who is Huygens? I will talk just a little about Huygens life and Huygens principle, Huygens construction for a spherical wave, and lastly, Huygens construction for a plane wave. First of all, who is Huygens? Christian Huygens is born April 14, 1629, and he is died July 8, 1695. He is an mathematician, astronomer, and physicist, and he founded the wave theory of light. Huygens principle. In 1678, Huygens proposed a model where each point on a wavefront may be regarded as a source of waves expanding from that point. The expanding wave may be demonstrated in a ripple tank by sending plane waves toward a barrier with a small opening. If waves approaching a beach strike a barrier with small opening, the waves may be seen expanded from the opening. You can see from the image. Huygens principle provides a convenient way to visualize refraction. If points on the wavefront at the boundary of a different medium serves as sources for propagating light, one can see why the direction of the light propagating changes. The Huygens wave would allow light to propagate into the geometric shadow. Particle wave of light would constrain the light to go to straight through the opening. According to Huygens principle, each point of a wavefront is a source of a secondary disturbance and generates spherical secondary wavelets, which spread out in all directions with speed of the wave in that medium. If a tangential surface common to all these secondary spherical wavefronts is drawn, then it gives the new position of the wavefront at a later instant. This surface involves all the secondary wavelets. Huygens construction for a spherical wave. To understand Huygens principle, let us now consider a primary wavefront A, B propagating in homogeneous medium. Then, according to Huygens principle, each point of A, B acts as the source of secondary disturbance. Secondary wavelets emanated from these points are spherical in shape and split in all directions at a speed equal to the speed of wave. If the speed of the wave is y, then in time t is the reaches of the spherical wave, which becomes yt. You can see the image t equals 0 a q r b, and v t equals time equal to t vt, and you can see the position of the a prime. Surface common to all these spheres in the forward direction gives the shape and location of the new wavefront after t seconds. In the image, a, b represent the location of the wavefront a prime, b prime represent the location of the wavefront a, b after t seconds. The secondary wavelets must be directed backward as well as forward from the secondary point sources. If this would be correct, we will get a surface such a double A prime, double B prime as a back wave, but experiment results don't show the presence of any such back wave. In order to explain these items, proposed that the intensity of the spherical wavelet is not uniform in all directions, but is maximum in the forward direction and zero in the backward direction. Hence, the wavelets as well as the wave always propagate in the forward direction only. You can see there is no backward direction. You can see just a forward direction, A prime and B prime, and you can see V times VT. It's another example, A, B, C, D, E. This distance is C times T. Consider a point source O of light giving rise to a spherical wavefront A, B, C, D, E at any instant. According to Huygen's principle, each point on a wavefront acts as a secondary source of light, producing secondary wavelets in all directions. Let C be the velocity of a light in the air and T be the time after which position of the wavefront is to be found. During time T, the light wave will travel a distance of Ct. You can see from here E traveling C times T. C is a velocity of light, T is the time. Then, to find the position and shape of the wavefront after time T, a number of spheroids of radius C times T are drawn with their centers A, B, C, D, and E. The tangential spherical surface joining the points A prime, B prime, C prime, D prime, and E prime in the forward direction is the new wavefront at that instant. The secondary wavelets are effective only in direction of wave normal. Therefore, a backward wavefront is absent. This is a new wavefront. A prime, B prime, C prime, D prime, and E prime. Huygen's construction for a plane wave. Now, let's us use Huygen's principle to find the location and shape of a plane wave front as a later instant of time t. That A, P, A, B, and P, a plane wave front at the time equal to 0. You can see. According to Huygen's principle, each point of FB acts as a source of secondary wavelengths. Radius of these spheres will be Vt after t seconds. According to Huygens principle, radius of these spheres will be Vt after t seconds. Complane touching these small spheres in the forward direction gives the shape and location of the new wavefront after t seconds. This is distance v times t. This is our new wavefront A prime and B prime. There is no backward wavefront. Another example, A, B, C, D, E. Consider a plane wavefront A, B, C, D, E at any instant. According to Huygens principle, each point on a wavefront acts as a secondary source of light, producing secondary wavelets in all directions. Let C be the velocity of light in air and T be the time after which position of the wavefront is to be found. During time T, the light wave will travel a distance of C times T. To find the position of shape of the wavefront after time T, a number of spheroids of radius C times T are drawn with the centers A, B, C, D, and E. The tangential surface joining the points A prime, B prime, C prime, D prime, and E prime in the forward direction is the new wavefront at that instant. The secondary wavelets are effective only in the direction of wave normal. Therefore, a backward wavefront is absent. There is no backward wavefront. Okay, my presentation is done. I edit my sources. Thanks for listening.